right, this film has been recorded in front of a live studio audience. You ready? We have an automobile depreciating or losing value as it gets older. Suppose that a car loses 1/5 of its value every year. So if the car started, maybe you bought a real clunker, you bought a $500 car, the next year, what would it be worth? It loses 1/5 of its value, so it would be worth 400 because it lost 1/5 of 500, so that's what it's worth next, okay? 1/5 of 400 is 5 goes into 400. The students say 80. 80 times. So if it lost $80, it would be worth 320 and so on. Now, I just made up a simpler example, I hope, than what we actually have here, because I want you to figure out if it's losing 1/5 of its value, what is it retaining? That's what we always care about. If it's losing 1/5, what is it keeping? 4/5, all right? To lose 1/5, what percentage is that? 20%. So if something is losing 20%, what is it retaining? 80%, okay? So if you're losing 0.2, you're keeping 0.8. See those opposites? You hear those opposites? Those are called complements of each other. 20, 80. 1/5, 4/5. They make up the whole, all right? So if we were going from term to term here, the common ratio would be, don't say 0.2, it's 0.8. It's always the percent that you're keeping from year to year. So as the car is losing 1/5 of its value, it's retaining 0.8. That's our common ratio. So I wanted to do that simplified example before we actually attack the real problem here. So we now know R is 0.8. That's what it's changing by. That's what you would multiply by to get the value from year to year. Write a formula for this car if when you bought it, it cost $23,999. That's going to be our U. I'll come back to that. $23,999. That was the cost of the car when you bought it. How many years have passed since you bought it? If you just bought it, 0. This is a perfect case for using U0 rather than U1. And I'll say this now, and I hope you understand it later. You usually use U0 in problems that involve time. Because when you first get something, how much time has passed? None. That's why U0 makes sense. Okay? To get to any other year, okay, you take the car's value previously, which we've talked about is UN minus 1, times what? Marley? 0.8 times 0.8. That's our recursive formula. All right? We're going to conclude the problem by finding out how much it would be worth when it's 6 years old. That means 6 years have passed since you bought it. That's how we age things in the United States. It's based on how many years you've been living, not how many birthdays you've had. To get the U6, that's what we're trying to find now, U6. 6 years have passed. This is how we know how to do it right now. This is using recursion. It's not with a shortcut or anything. It's simply going to be 23,999, enter. That goes into your calculator's memory, times 0.8. By multiplying by 0.8, what percent did we lose? 20%, which is 1/5. Good. All right. You hit enter. The car is 1 year old, and now it's worth $19,199. After 2 years, it's worth $15,359. 3, 4, 5, 6. After 6 years, the car is now worth $6,291.19. Only 6 years ago, it was worth $24,000. So that's depreciation. Thank you, and good night.